what you'll be asking, okay, how do I compile the code? How do I run the code? All right, so to compile the code, you can choose what compiler you want to use. I want to use G++, so I'll type G++. That specifies what program I want to run. And then I'm going to provide it a couple flags. Remember from before that, like they're kind of like, flags are kind of like parameters. You can specify exactly how you want the program to run. So I'm going to specify, I want std, which version. I want it to be C++ 17 or 20. And let's just do 17. Okay? And then here you specify what file you want to compile. I want to create, I want to skip the, there's a long, complicated sequence of how do you compile files. We're just going to do something simple, which is going to use the flag. So after compiling, what happens is it will turn the CPP file into like a binary that you can run. I'm going to just name the binary hello world. Okay?
Sorry, could you repeat that line?
Yeah.
That when we're there.
G++ means I want to use the compiler G++. std17, the dash std equals C++ 17 means I want to use the C++ 17 standard. Hello world is the file I want to compile. Dash O, you don't have to understand too much about this, but there are many stages in compilation. I'm just gonna make it skip everything. I just want it to compile the file and give me the binary executable. Okay? So just add the dot dash over there. And then hello world is the output final, like the name of our binary. Okay, if I run this. Okay, so once you run this, if you click ls one more time, you'll see that that there is a hello world binary over here. Hello world. Essentially what happened is the compiler took the hello world CPP file and it turned it into an executable. Okay? I don't know if this, yeah, so yeah, if I run the executable, so it's kind of like any executable you download. If you run the executable, then something pops up and it runs the program. Hello world. Alright? If you want to run the program from your terminal, what you do is you specify you basically specify what the directory you want to run it in, which is dot, and then we say / hello world. This runs the program. Cool, right? Cool. Alright, let's write a more complicated program. Okay, so remember, I'm using Vim to access hello world.cpp. Let's read it in. Let's read it in. Int number, c number, cout. Okay, remember, you don't want to really use C with the alligator. You should be using what? Getline, and you should also be using string streams to parse. Okay, but just as an example, suppose we type this in. Okay. Does someone want to remind me, what do we have to type to compile the program?
Sorry.
First thing is the compiler you're using, G++. Second thing?
Standard C++.
Yeah. So we want to type in what standard we're using. You don't have to type this in, but if you don't type this in, C++, depending on what your compiler is, it will default to the one released in 1998, which kind of sucks. So I encourage you to type in the version. You can also do 14, 17. Just for fun, let's try 20. I don't know if they released it, but maybe. And then what's next?
Minus oh, hello world.
Yeah. The file you are trying to compile. What's next? Dash O, yeah. Dash O basically just skips the complicated stages you have to compile. I'm just gonna skip everything, just go from the file to the executable. Yeah. Dash O means the object file. There's like an intermediate object file. Let's just skip everything, go to the end. And then what's the last thing? Hello world.
Was that overwrite your previous thing?
Yeah. Oh. C++ 20 is not released, but you can use C++ 2a as the working draft. Let's try that. This is cool, right? You can actually run C++ 20 code, which has not been released yet. Okay? And then, okay, how do we run the program itself? // hello. Okay, so we asked for cin, so it's waiting for us to type in some input. 15. We typed in 15. Hello world. Okay.
Avery,
Question.
just with the dash O, is that like what you name your
Oh,
font? Sorry, tell.
This one?
Yeah.
Yeah. So the very last thing is what you want your the executable to be in. Yeah. So if you look in the actual folder itself, you'll see that hello world is actually an executable. Kind of like anything you download from the internet. You can click on it and it runs it. Maybe not. Never mind. It should. Oh no, yeah, because I have to type in something. 15. Ta-da. All right. Quick word of advice. Don't do this. Don't do point period slash and then some executable you randomly downloaded from the internet that you don't know what it is. All right, because that is just running a program inside the terminal. So don't don't download some sort of file and then start running it without thinking what it is. Okay? Don't just randomly run executables. But if you wrote the executable, then sure, run it as much as you want.
I mean, that's the general piece of advice.
Yeah, but specifically don't run it in the terminal.
Very true. To have better authority.
Depends on for example, I can run an executable using root privilege, which means sudo. Yeah, so what sudo means is sudo means root access. Give you know how in your computers you have different users. There's also a root user who has administrative privileges. Running programs in that setting is pretty dangerous because then your program can change the root settings. It can change basically your laptop, how your laptop's running.
That's sketchy.
That is very sketchy. So don't type sudo. Don't use sudo. Okay. Any questions? Just some other fun commands. Don't memorize these because you'll get used to them. But one command you can use. Let's say we're going to documents. So let's go to documents folder. It currently just has the lecture video. Okay. You can make a directory. mkdir. That means make directory. Okay. Let's make a directory called code. Ta-da! It appeared. ls. Yeah, you can see it. All right. rm means remove, so I can say rm code. If that doesn't work. rm, you can remove a directory. If you want to remove one file, you can do rm that file. If you want to remove a directory, you can remove it recursively by doing rm -r code. Okay, yeah. So rm code, that means remove the directory. But because it's a directory, when you remove a directory, you also have to remove everything within that directory. Yeah, that's why it's called it's recursive, and that you have to go into the directory, remove everything there, and then go back out. Okay? Have you all heard of the really dangerous line you can type in? Sudo. Okay, I don't want to type it out. But you've all heard that line, right? Okay. I don't want to type it out. Okay. rm, and then dots. Okay, so
Does that clear your whole, wipe your whole computer?
it won't because I didn't say sudo. Because it's not allowed to wipe everything. It's only allowed to wipe what it has access to. So my user only has access to my account. But yes, I can wipe my whole account if I want. All right. Now delete. Wait. Delete. Okay. So R means recursive. It means go into the directories and remove everything. It means go into the directories, remove everything. If you have more directories, then go into those and remove everything. So it's like removing your entire directory.
Your entire life.
And then what rf means is if you just do it -r, it will ask you, are you sure you want to remove this? It will go through each file and it will ask you, are you sure you want to remove this? Are you sure you want to remove this? Guess what F stands for?
Quiet.
F stands for force, which means you're telling it just remove it and just forcibly remove it. Don't ask me.
It's like force of it, but you're into everything.
Yeah. Okay, and then remember what dot means?
The directory.
The current directory, yeah. So that line means remove everything in the current directory and do it recursively, which means go into all the directories and remove everything in those.
So,
And do it by force, so don't ask me.
So could you do this
Okay, wait. But before you go on, let me just
wait, I
say
didn't
something.
understand that dot.
Okay, yeah. So if you go into so ls, what ls means is ls means list all the files in the current directory.
Oh, desktop. Oh, that's what that was.
Yeah. So if we do ls, it has this file, right? That's one file. I can make another directory, code. Yeah. And if you do ls, it shows code and that. Okay. Okay. Sure. All right. Let me get started, okay? But if you have more questions about this, let me know. Hopefully this is helpful. You can run your programs. Hopefully. If you came in late, well, that's your fault. All right. Let's get started. Where's my? Wait, CS106L. Down with the slides. Okay. Alright, so as I said from this set in the Piazza post, if you have questions during lecture, feel free to ask them, but what I'll be doing is I will have a special, I'll have specific slides which say question. So save your questions for those slides, okay? I kind of want to finish a whole chunk before I get to questions. Secondly, make sure your questions are directly relevant to the material we're covering right now, or is like something that in like the previous slides, okay? If your question is like of the form, what if you did this instead, or couldn't you do it this other way? I really love those questions. Save those for after lecture, okay? It's just to make sure that that we can all get through the material and essentially keep my flow going. All right? Cool. All right. We're not going to cover all of these today, but we'll cover some of them. So, just a quick review. Last week we wrote this thing called the generic min-max function. All right. So, just a review. What does the template type name T do? Andy? Yes.
It defines like a custom type.
Yeah. So we're specifying that what we're going to write is a template function, and then specifically it's going to use this template parameter T. Okay. And then we just replace all the instances of T of whatever we assumed our type is to be T. All right. How many of you did the homework? Okay. Cause like. So 4? Okay, because more than 4 people in the feedback said that they wanted more practice questions. So, but only 4 of you did the homework. So the homework was look at the slides and finish and essentially make the function mismatch be more generic.
I looked at it.
You looked at it?
And then I looked at the answer 3 slides down.
So what I'm getting is I shouldn't release the answer. Okay, got it. Oh, also I forgot to do this whole screencast thing. Do you all just want to watch the video today? That's fine. Okay. Alright, okay, I'm not going to spend time on this because you were supposed to do it. So I'm going to skip it. But essentially, what you were given was a mismatch function for like vectors, and you had to concept lift it by making it as generic as possible. So here, mismatch can take in input iterators of like one range, and it also takes in an input iterator of the second range. Why don't we have to pass in like the last 2? We had to pass in first one and last one. Why don't we have to pass in last 2? All right, actually, since most of you didn't do the homework, I don't know why I'm asking this question. Anyone have an answer? Okay, so the reason is because mismatch, it basically goes through 2 ranges, and it finds the first instance where the ranges don't match. Okay? The thing is, if you already know the length of one range, you should know the length of the other one. That's why you only have to pass in the first and the second. Okay? This will appear multiple times today. And then this function essentially just goes through the ranges. It just goes through both ranges, and it finds which one doesn't match. Okay? This code, yeah,
But what if like input 2 is shorter? Then like in the case of pointers, right? If you access something weird, what's the problem, right? So like how do you know that that's not an option?
Yeah. So remember that one philosophy of the C++ is it will give you the interface and it will tell you what it expects. And if you decide to not follow that, then it will not try to stop you. Yeah. So it basically tells, if you look at the documentation, it tells you that the 2 ranges have to be the same size. Right? It doesn't really make sense to compare 2 ranges if they're not the same size. Right? Then obviously there's going to be a mismatch. So it assumes that, and then if you don't follow it, then if you don't follow it, then it just reads up to And if your first range is shorter than your second range, if your first range is longer than your second range, then it just tries to read whatever is over there. Okay? Cool. Alright, let's skip that. Alright, today we're going to focus on solving the last two tasks here. Okay? Well, we did already solve the second to last task, and we're going to focus on how do we solve the last task. Okay? Because last time we already wrote a generic function, count occurrences, which can take in any range, like the second half of a list of strings, and like some data types, like 5. Well, string 5. Alright? Now, the issue is, okay, well, typo here, this should be an int probably. But we're gonna try to solve a more generic question, which is count how many elements in a certain range. But instead of just being equal, we're saying, okay, are at most 5. Okay. But before we get to that, let's quickly talk about generic programming concept lifting. So, concept lifting is the process where we're looking at the assumptions we place on the parameters, and we question if they're really necessary. Right? So remember last time, we started with count occurrences for a vector of ints, and it tries to find how many instances of that int. We generalized it to make it allow it so that it can be a vector of any type. Then we generalized it even more so it can be any container of any type. We went one step further, it can be any range. We can count the occurrences in any range. Okay? But while you are doing that, you have to be careful about what you are assuming about your parameters. Okay? And that's where implicit interfaces come in. So, suppose we try to call this function, so using what we did before. Okay? So we have a v1, we have a v2, and then we want to count, we call count occurrences on this. Now this doesn't make sense because we have like a range and another range, but we're going to try calling it anyways. What's wrong with this code? So let me just say what I'm trying to do. I'm trying to count how many occurrences are in v1 of the first element, because begin points to the first, is an iterator to the first element, right? Why doesn't this compile? Okay, as a hint, let's look at the code. So what the compiler does is it basically tries to infer what the types are, and it literally just puts that into the code. So if we just look at the type, what's the type of v1.begin? Yeah, it's an iterator of for vector events. What's the type of v2.begin? Same thing, right? So if we go into here, what it does is it literally tries to infer what these types are. That's it. Okay, but then that causes a problem in this code down here. Can you see what the problem is?
Dereferencing the iterator is somehow giving you iterator.
Okay, so yeah, notice in this line we're saying dereference the iterator. What should that give you? An int, right? And then we're comparing that to see if it's equal to val. What's val? Okay, so we're comparing an int to an iterator, which is not allowed. All right. So this is what implicit interfaces come in, which is when you declare templates, you can literally try to plug any type into the template. Sometimes it will work, sometimes it won't work, and the compiler will enforce which types do not work. And how it determines that is it goes into it looks at the operations you're doing with those types, and it sees what those types have to satisfy. Okay, so you just pointed out one good type, which is when you dereference iter, it has to be comparable to val. Okay, that is one requirement of these types. When you dereference one of these types, you have to be able to compare it through equality to this type. So if this is a vector, if this is an iterator and this is also an iterator, that doesn't work. If this is an iterator and this is an int, that works. Okay, make sense? All right. Let's look at what other sort of requirements do you see for input iterator and data type. There's some other requirements that this function imposes. What are some of those? Good question. Okay. So here it says that begin must be copyable. Yeah. So not all types are copyable. We'll learn that later. But here we have an enforcement that we have to be able to copy whatever input iterator is. Okay. This is important. The iterator, iter, must be comparable to end. One sec. Here we also see that, okay, for this code to compile, you must be able to increment iter. Can you think of types where you cannot increment? Types that are not incrementable? Yeah, strings. You can't increment a string, right? So if we try to pass in a string for iter, that would not work. Right? Did you see how these are causing like these like implicit requirements? We're not explicitly saying what the requirements are, but the code itself forces these requirements. All right, let's do some questions. Question, yes.
Yeah, so you're talking about how begin isn't necessarily assignable for all types. Would a string be an example of that?
Yeah, great question. So one thing that cannot be copied is a string, right? Like if I asked you make a copy of cout, that would not work. Because I mean, imagine if it did, what havoc it would cause, right? You have copies of couts going around. Yeah, there are some things that are just not copyable. If you're taking CS106B or X, you'll know that you have to pass in file streams by reference, and the reason is because streams are not copyable. So if we try to pass in a stream to here, this implicit interface would not work, right? This forces that you have to be able to copy something from begin. Another thing here is that you have to be able to compare your iterator to whatever end is. And then here we force that iter has to be incrementable. Okay, another question, yeah.
Well, you declare it iter by auto, so like if you give it weird restrictions, will it really try the very best it can to find something that fits all the constraints?
Yes. Yeah. So suppose we gave it not an iterator, we gave it like a string, right? Then this would work because auto infers that what you pass in is a string. Okay. Now you mentioned that as in like it will try to do the worst it can to find what type it is, and you make a good point, which is auto will do anything to try to figure out what the type is, right? And then even if the type is wrong, then that's good. So this is not itself the implicit interface, but the assignable, the copyable part is part of the interface. Okay. Now we speak of auto as if it's a bad thing, but imagine what you would have to put here instead of auto for this to compile. Right? If we did not use auto, what type would you have to put here? Input iterator, right? Because the type of this should be an input iterator. It's copied from an input iterator. Okay? So in this example, it's fine, just plug that in. But sometimes your types will be more complicated, in which case auto is a nice way of saying, okay, figure out that type for me. The real interfaces come later when you try to define the other parts. Okay? We also, before we mentioned, this is the place where the implicit interface failed, where we're trying to dereference input iterator, and it has to be comparable to your data type. Okay? So the templates impose these sort of requirements on what the type is. All right, questions? Yes?
So when you pass an iterator to that function, is it automatically passed by reference?
By default, here we're not passing it by reference, we're just passing it by value. So you can also do an ampersand to say, okay, I want it to specifically pass by value.
So we are actually making a copy of that iterator.
Yeah, you bring up a good point. Inside here, we are already making copies of the iterators.
And when you do that auto iter equals begin, does that also make a copy? Okay.
Yeah, it makes a copy. Good question. So this line does make a copy of begin. Okay. Iterators are for most types. Iterators are relatively cheap to copy, so it's fine passing them by a value. Other questions? Yes.
So why can't we increment the iterator that points to a vector of strings?
Let's see. Why can't we increment an iterator that points to a vector? if input iterator was an iterator for a vector for a string, sure, that would work. But if begin itself was a string, then okay, we try to set iter to begin, so that should be a string. And then we're trying to say, okay, take a string and do plus plus on it. That doesn't work. Okay, I'm not going to do that example, but if you try compiling this code, what you'll get is a list of nasty errors. Okay, there was once this programming online competition where the goal is to write as few lines of code as possible and try to generate the most amount of errors. Okay, the way to win that is to use templates. What the template does is, if it finds a mismatch. Last week I mentioned these like auto deduction rules. It will try to try every possible type, and it will try to like basically try everything possible, see if anything works. If it doesn't work, then it says, oh, none of these work. All of these are errors. So you'll get these like really long messages. I already debugged some students' codes where you see like these gigantic, enormous number of errors. And the worst part is the error messages are horrible. Like, they don't help at all. So that's one of the hard parts about templates. Question, yes.
So what types of things should we look for to say this is an iterator problem in the error code?
Yeah, good question. So when I don't have an example right now, but if you go to Qt Creator, sometimes the errors, it will say error code 1.
Yeah.
Anyone ever get that error code 1? Yeah, something like that. Well, if you get that, you should go to the compile output tab, where it will show you all the errors, and look for the line of code that you wrote. Okay, because there are a ton of errors. A lot of them come from like the iterator library. So you should be looking for the code that you wrote. You should be able to see main something, which is like what you wrote. So that's how I would start debugging these errors. They're hard to debug, which is why there's a C++20 thing coming out, which will help with templates. And it's actually one of like the most important C++20 thing. It's called a concept, and I'll talk about that next. Well, probably not. I'll probably skip over it. Okay. Okay, I have one more example. Okay, take this, turn to your partner for 1 minute. Discuss what the implicit interface of this function is. Go. What requirements must be true about collection and data? I'll split it. Okay, yeah. Because this is the and then lambda is also. All right. So, for people who want candy, someone tell me a restriction that's placed on collection or data type. Back there, yes.
Does a data type need to implement a comparative function?
Let's see. Does data type need to implement a comparative function? So, where's that relevant?
As equals?
Here, right?
Yeah.
List, yeah. So when you do list bracket I, that should give you an element of type data type.
Do they automatically know to compare data type equals data type?
Should be. It should be able to. Although one thing you should.
If you define your own class, though.
Yeah, if you define your own class, it may or may not be
Right.
comparable. So yeah, that is a good point. That's definitely an interface. What, Candy?
Whatever you choose.
Too late. I've chosen for you. Okay. Yes.
You need to be able to access the data type using the bracket notation.
Exactly. Good point. So list, this collection, it has to have the bracket notation. Okay. So what's the type that does not have the bracket notation? Maps technically do, but it's not what you expect it to do. Yeah. Like a list, a set, anything. Yeah. Okay.
Sure.
What kind?
Just whichever one.
Okay. Yes.
It has to have the dot size method.
Yeah, good point. So list has to have a dot size method. What classes don't have a dot size method? Sure, stacks. Well, stacks don't have a stuff.
String, no.
Yeah. Okay. Cool. Candy.
Sure.
Okay. If you say sure, I'll assume that means anything. All right. Anything else? There's a few more.
But do you have to, are some data types like not allowed? Like
Yeah.
even existing, like not necessarily ones that you made yourself, are there some data types that wouldn't work?
That's a good point. So if, when you're dealing with a collection like a vector, every time you put something into a vector, it makes a copy of what you're putting into the vector for a collection. So your data type has to be copyable. Yeah. Andy?
Yes. I'll enjoy it.
Back there, yes. Sorry.
The collection has to be able to be, like, has to have indices of size t, and that means it also has to be, like, ordered already?
Yeah, good point. It has to be a sequence container, right? Well, not just any sequence container, but this is pretty much only exists for vectors and index. Okay? Lists don't have these. Yeah. So, yeah, good point. It has to be indexable. Yeah. Candy?
Kit Kat?
Kit Kat. Okay, this is not gonna work. This is not gonna work. Close enough. Yes.
So when you declare collection, like that there's brackets data type, does that already imply that it is some sort of collection? Like there are multiple things inside to the
good-
brackets and whatnot?
That's a good point. I think that this might be a mistake. I might actually have to remove this. That's right. I should remove this. Yeah. Okay. Yeah. Good point. This should not be there. And then the collection itself should be able to infer that it is a vector of strings. Okay, yeah. And then that does pose a requirement, which is the collection, the stuff inside the collection has to be of type data type. Candy? Okay. Yes.
So if you had typed it like that, would it still be able to compile, assuming that you happen to have the?
I don't think this would compile it.
Okay.
Yeah.
The other thing you would still need to keep the reference though. So templates don't assume references.
All right. I'll fix that.
Can you say what that problem was again?
Yeah. So here we should not put this angle bracket because the compiler will try to figure out what type is collection, and it will say, oh, it's a vector of strings. Yeah. So it doesn't have to be the angle brackets. Now that is one additional requirement, which is whatever is stored inside the collection has to be of type data type. Yeah. You can't have this be a vector of strings and this be an int.
And or have it be comparable using equals equals to the data type. So if for some reason you have another equals equals line.
So let's just go through them. Size, yes. Okay. And you all caught a few more, so that's great. All right. Let me just quickly talk about something in C++20. C++20 allows the programmer to explicitly specify what the interface is. So here we explicitly say that that IT, whatever IT is, has to be an input iterator, and IT has to be probably missing a comment here or something. Value type of, if we dereference the iterator, it should be comparable to type. I think that's what it means. Okay, again, this is a C++20 thing. It's not formalized yet, but this is what C++20 is going to do. And what this allows is if you break one of the interfaces, the error message will not be a terrifying amount of error messages about here. The error messages will stem from this. So instead of an implicit interface, this is a explicit interface. Okay? Explicit is always better than implicit. Okay? And then also in the documentation, you'll see this, which is self-documenting. Right? You know exactly what it has to be. It has to be an input iterator, and it has to be comparable to when you dereference it to type. Okay, cool. Let's do some questions. Yeah.
Can you explain the difference between implicit and explicit description of data?
Sure. So here, looking at this code, let's do this one. Yeah. Looking at this code, we just try to figure out what the implicit interface is. Right? We try to figure out what requirements have to be true about input iterator and data type. But it's not explicitly written on here. You have to actually go to the function, go step by step, figure out what has to be true about these templates. That's not great, especially if you're only given the documentation. You don't exactly know what has to be true about input type and data type. So to make it more explicit, now you can do something like this, where you explicitly say that it has to be an input iterator, comparable, stuff like that. We're explicitly writing the requirements in code.
Oh,
Okay. Any questions? All right, let's move on. So functions and lambdas. We're speeding through this today. So we talked about concept lifting. This was the function we wrote, and it solves the question: how many times does some type, some value appear in a range of elements? We can make this a little bit more generic. One way to do that is we can look at this part, and let's rephrase that to: how many times does the element satisfy equal value in a range of elements? Okay? Same thing, right? This is the same, doing the same thing. Agreed? Okay. Now, we can generalize a little more, because equal value, we can replace that with something else. Right? We can replace that with: how many times does the element satisfy less than 5 in a range of elements? It doesn't necessarily have to be equals value. It can be any sort of true or false condition. Right? And that is known as a predicate. A predicate is a function that takes in some number of arguments and returns a boolean. For example, is equal to 3? Well, we have a function. This is a unary predicate. It takes in one argument of value and it returns if value is equal to 3. We also have binary predicates where it takes in 2 arguments and then it returns some true or false value. Okay. So instead of saying how many times does the element satisfy equals element, you can replace that with some generic predicate. And even better, now you can pass in some generic predicate over here. Okay, can you see how this is like even one step higher than the count occurrences we wrote before? Before, it has to be how many elements are equal to a certain element. Now it's how many elements satisfy this condition. Okay, yeah, and then we can do something like this. This is really short, so I don't want to write the code, but you can do something like this, where you can define a function is less than 5, and then you can call count recurrences on v.begin, v.end, and then pass in the condition. And what happens is it will try to run this condition if predicate of that thing. It tries to call the predicate on every element, and it increments by 1 if that predicate returns true. Okay, this is kind of really important. So, any questions right now? Question, yes.
So is predicate a function in this case? Like, so you're running a function as a parameter?
Exactly.
Okay.
Yeah.
So you'd have to list out, if you wanted to make it generally, you have to list out a bunch of different predicate functions. You have to write them out specifically.
Yes, so there is a syntax for a function. Function pointers? Yeah. You can explicitly write out function pointers, which people do that a lot in C. But because you normally don't have to do that normally, so we're not going to do that. Yeah, but it's better to just do it at the time.
And remember that we can also templatize functions.
Yeah.
Yeah, there's also a type called std : functional, which is like a catch-all for any kind of function. So we can try to do that. You can put that as well. I think that works. Okay. Yeah. So then we can call the function using this, and then that should return true. Okay. And then yeah, we can make a lot of different predicates. Right, these are all predicate functions. Don't worry about this inline. It's not super important. But we can write a bunch of predicates. The only requirement is it has to return a boolean, and it has to take in some number of arguments.
And going back to your question,
Andrew.
and going back to Andrew's question, notice that even in our predicate, we can make our predicate function a template function itself. So we're using template functions as a parameter in other template functions, which is really cool.
Kenny?
Oh, no, good.
Yes.
So predicates don't have to be Boolean, right? You can have them calculate a value and still call them the same way?
Predicates have to return a boolean.
Oh.
Yeah, because the way we're going to use the predicate is we're going to say, okay, we're going to call the predicate on something and see if it returns true or false.
In this case, but in other cases, it's always a Boolean?
Yeah, we use the term predicate to mean it has to be a boolean. It has to return a boolean. A function that returns a boolean. Yeah. Question, yeah?
So when you say that predicate takes some number of parameters, can the number be 0? Does it need some parameters?
Yes, it can be a no parameter function. I think those are called in CS 110. Those are called funcs. THUNKS. Yeah, thunks. Those are, you can do those, but for the cases we're going to do today, they're not going to be really helpful because, I mean, then you're just calling the same function on every element, but you're not taking any parameters. Yeah. Like, yeah. Oh, a function that doesn't take any parameters is not really customizable, right? It just runs the same thing every time. So,
And another note to Michael's question, I think maybe what you're asking is there any case in which we can pass in a function
Right.
that is not a predicate? There are cases where you do that, and we actually saw an example of that in one of the algorithms in an earlier slide, and I think Avery may or may not be, or will be covering it in the future. In that case, you just wouldn't call it a predicate, but yes, you can pass in functions that do like a specific thing that is not returned. Yeah, in this case, you.
all right. So yeah, these are some predicate functions. I really like this one. My bedtime is at 4, so that's my bedtime. Okay.
AM or PM?
AM, of course it's AM. Okay, and then we can do something like this. This is like a vector of numbers. This is like my sleep times in week 4, right? So you can say, okay, here's I can pass count occurrences, count how many of them are less than 2. I can say how many of my week 4 sleep times are past my bedtime. 1, right? All right. Any questions? Okay, there are 2 major problems with this approach. We call this like the function pointer approach, where we're essentially passing in this other function. Anyone see what a problem is? Any problems with code like this? Yes. Yeah.
It's not very explicit, so it's not clear to the person using it.
Yeah. It's very. Do you mean like it's explicit and then you have to say less than 5? And it's specifically 5. Is that what you mean?
No, but it is now.
Oh, okay. Sorry, okay. I didn't catch your point then. What did you say? Yeah.
I meant that when you're using the function, the person who's using it might not be sure how to use it because it's so general.
Yeah, sure. So, for example, one thing is you have to write the function. Someone has to write the function, and then you have to essentially know what function to call. Right? So that is a good problem. Another problem I gave the answer away, which is, okay, this works for is less than 5. You'll have to do something like this, right? Okay, what is, anyone notice one thing that I did not try in this example that you might want to try, right? Like you're saying, okay, why do I have to hard code these?
Pass the second value you're comparing it to.
Pass a second value to compare it to. So I can try, instead of passing just one value, I can pass a parameter, right? That's how you customize functions, right? You can pass in more parameters. The problem is, what's the implicit interface for predicate? When you call predicate, how many parameters do you pass in? 1. So if you try to declare another predicate that has more than 1 parameter, this code will not compile.
So like overriding a function?
Overriding a
How
function.
does like in C++ or Java or whatever, when you have like a function with the same name but a different number of parameters, how does that work?
Different number of parameters. Overloading function. The problem is because we wrote this, like, this is a function you're calling, and you can't really change that function.
Okay.
Right? We're writing our own code, but you can't change,
But
like,
how does it know which one to keep?
takes. Well, can I answer that question after a little bit? Sure. Yeah, because I know what you're saying, but it's a longer explanation. Yes, question.
Pair. Use a pair. If you want to send in order to compare.
But the problem is for that is, so you're saying that predicate takes in a pair. Let me get you back on that one. I don't think that would work. Yeah, because the thing is, the predicate function doesn't know what it's taking in. It may take in 1 value, 2 values. So I'm not. Let me get back to you on that. Okay. So one thing you might try to do is, okay, let's do a limit, right? But then you can't really pass in this limit into here. So that's a problem. You can't add it as a parameter. You can't add it as a parameter because then this is not a predicate function. I really want to get to code, but I don't know, I don't really want to pull up the code. But if you try to do something like this, it will show you a ton of errors again, saying that it will tell you exactly this line of code does not compile. And the problem is that this code is normally in some library that you did not write. So you'll be told, so okay, I love Piazza posts like this, which say, the Stanford libraries are broken, the errors are telling me that the error message is telling me that there is a problem with the Stanford libraries, okay? Because when template errors happen, they point you to the source, the exact line that does not compile. The problem is you passed in something that does not compile, not the line itself does not compile. All right? I love those Piazza messages, and then some nice section leader named Anand will tell you politely that your code is broken. Wait, do 106B students know what I'm talking about? Okay, never mind. He's not answers Piazza questions. Okay. Okay, fine. There's a section leader Anand who answers questions really bluntly.
And really quick.
And really quickly, yes. Okay, yeah, so the pre-C++ 11 solution is to do something like this. Okay? Now, this topic is really dear to me because when I interviewed for this job, this was the thing I presented on. Okay? But this is kind of complicated because you have to learn about classes. And then it seems kind of an overkill to write an entire class to write one predicate function. Okay, so we're not even going to look at this, but if you want to learn about this, let me know. Okay, we can learn about this in later lectures if you want. But the C++ 11 solution is to use this thing called a lambda. Okay, that's this line over here. A lambda is basically a very lightweight function that you can create, and that function acts. It's an object, but it acts like a function. Okay, let's just do an example. So I don't really have this prepped, but we can do something like this. There's a lot of code. So let's create a simple lambda. Let's say is less than 2. Okay. Don't worry about the syntax, but int I, and then return I is less than 2. Okay. So I just declared a lambda. Don't worry about this complicated syntax. Now, this object, this is an object, right? This is a variable which is storing some sort of object. This object acts exactly like a function. So, what can we do with a function? Call it, right? Okay, so let's say less than, and how do you call a function?
Parentheses.
Yeah, so we say is less than 2, let's put it in 1, that should return true, false. True, right? And then if less than 3, false. Okay? So we're just declaring an object that acts like a function. Some people call these functors. And then you can use them exactly like they are functions. All right, so for example here, we have a bunch of grades. We use a bunch of student grades and calculate how many of them got an A. Right? And then here, we're passing in, this acts like a function, and then we're passing in functor. Now, let's break this line down a little more. Let's look at the syntax, because the syntax, some parts may look really familiar, other parts are not. The anatomy of a lambda function looks like this. Okay, so you have your declaring a functor. You have this thing called a capture clause. Then you put a bunch of parameters, this return type, and then you have a body. All right, this return type in C++ 14 is like pretty optional, so you can usually just eliminate it. Usually for predicates, they return booleans, so you don't really have to say that. Okay, so parameters, yeah, exactly as you expect from a function. It takes in some number of parameters. The cool thing about lambdas is you can use auto for the parameters. Okay, so let's just put auto, and then for the body, it just works exactly like a function. Put whatever you want inside your function. And then, yes, this so far. I'll stop right now. Are there any questions so far? Yes.
So I know generally we want to have stuff be auto if we can, but in this case, should we say bool to like make it obvious that it's a predicate?
You're saying the return value?
Yeah, the return. Well,
the
I
parameter.
guess at the beginning. What it's auto? Okay.
Oh, you're just saying this. So there's two autos.
Yeah.
This auto or this auto?
The first
The
one.
first one. Okay, that's a great question. So, the question is, this is a functor. What is its type? C++, that works in Java because everything's derived from an object, but C++ doesn't have an object type. Okay, so here's the cool thing, okay? When you write something like this, C++ takes this and it converts it into this. It creates a class for you. Cool, right? But the problem is you don't know what the class is named. The compiler will name it some sort of really bizarre name, and you really don't know what the name is. This is where you have to use auto, because you really don't know what the name is.
Okay, so then as far as the return type after the bracket, is it,
This one?
yeah, would it be just good use in that case, just to make it obvious to those reading that it's a predicate function? Maybe.
People have different preferences depending on like what style you prefer. Because a lot of the times we use lambdas, we often use them for predicates. In which case, it's implied that it returns a boolean.
Okay.
There are other cases where you want to use lambdas. If you take CS one time, you use lambdas a lot, where it might be helpful to explicitly say what the return type is.
Okay.
But it's just as C++ develops more and more, people get more and more lazy. Okay. Any other questions? Okay. This does not compile though. Right? It's the same issue how we had before. We can declare a limit, but it does not, this creates its own scope. So anything inside here cannot access anything outside there. In some languages, you'll hear this is called a closure, and that's the reason. It encloses like a function. It's like a function that encloses its own variables. So these don't interact. Anyone want to guess what the capture clause does? It captures the variable, exactly. So we can explicitly say, okay, capture that variable that lives in this scope and make it available inside our lambda function. And this code works perfectly. Okay, questions? Yes?
If you change the value of the variable after you call the functor and then call like your counter parentheses, will it refer, like which value will it refer to? Is it taking the exact current state that's available?
Good question. I think it's a current state. Right? It's the state that you declare in this function. So it's basically pulling in the value limit. But
We'll double check that though. That is
Okay.
yeah, okay, I'm pretty sure about that because then what happens is you might have like dangling stuff. Right? Like what if limit goes out of scope?
let's see, this is my file.
But because I'm pretty because this takes a copy. Oh, references versus copies. Yeah. Okay. Yeah. Good question. And that leads exactly into what we're going to talk about. You can capture these variables by reference or by copy.
So
Okay.
in this case, you're right, it would take the one at that
Yeah.
time.
Okay.
Yes.
Can we not just pass it in as like another parameter next to auto val? Is that,
Good question. So you could, but then you run into the same problem, which is here, the implicit interface of predicate only takes into one parameter.
oh, okay,
Yeah. Yeah, it's the exact same issue that we dealt with before. You can't add any extra parameters. So that's why we explicitly had this thing, which allows you to capture variables without counting them as parameters. Okay. Let's just quickly talk about. Here's another tea example. I was biking over here and I lost my bottle of tea that I usually have, so I'm kind of thirsty right now. Yes. Okay. There are more ways you can capture these variables. You can capture them by reference. So for example, a set of strings, we don't really want to copy that, so you can capture it by reference like this. You can specify which ones you want to capture by reference, which ones you want to capture by copy. Questions? Yes.
If you're like capturing everything with like this kind you can do, would you want to do that by reference so you don't copy large things within that like T's?
Let's see. T's. Yeah. So here you want to put the ampersand before T's to say that I want to copy it by. I want to copy this variable by reference.
Yeah.
Not copy by reference. I want to pass this. I want to capture it by reference.
Yeah, but like typically if you're like capturing everything in a class, like because I know you can capture it like everything with this. Would you do like ampersand this just so you don't copy everything?
Let's not talk about this because this will come up later. Yeah, when we talk about classes. But list by default is a pointer, so you can copy it by value.
Okay.
Yeah. But okay, so there are also ways you can just capture everything. So if you do an equals, that means capture everything by a value. And then if there's some things you want to particularly capture by reference, then you write that afterwards. You can also capture everything by reference and then accept whatever you write, that's by value. Okay? Not recommended, because this kind of like makes it global, right? It captures everything. So that's kind of like a global. Okay? It's like capturing everything that's available into your function. Okay, we'll talk about this next time, but I'll basically give you an overview of what's going to happen next time. We're going to we're going to essentially use the STL algorithms library using this new knowledge of functors that we have. Okay, and what's going to happen is you'll see that count occurrences, what we wrote today, that is actually an STL algorithm called countif. Okay, and then there are a ton of other algorithms which are extremely customizable. You can pass in a functor and pass in a lambda, and it will do what the library said. Okay, and then we'll do some really cool stuff. I have an example where I have essentially everyone who filled out the survey for assignment 1. I created a file which has your name, your year, and also your grade in 106B. Okay, and then and then we will do some tasks like did anyone fail?
Wait.
That's a dangerous file.
Okay, I'm just joking. I did generate random numbers for your grades. So, yeah, there will be random numbers, but no, those are not, like, especially if you're in 106B right now, those are not your correct grades. Those are your predicted grades. So, yeah.
Which is to say we predict you all to get 100% because you're taking this awesome class. Just kidding, just kidding. Also, to answer your question, okay, to answer Mish's question, functors use the value of the capture class at runtime, not at when they're released. So when it's called, not when it's
So you have 3, and then you will probably get 1. And then they're automatic. We need more
I think I'm going to do it by reference. I'm going to use it by reference.